Hello everyone, and welcome back to another video. Today we're going to be continuing the series on limits, and I'm going to be teaching you how to evaluate some simple limits that might look confusing if you've never tried to do them before. So let's get into it. The first concept I want to talk about involves a graph like this. If we have y equals 1, no x, nothing, just y equals 1, what would that look like? Well, that's easy. It would be a straight line. It extends forever at y equals 1. It's easy. Why am I talking about this? Well, what if y were equal to, instead of 1, x over x? Well, x over x, it doesn't matter what x is. It's always 1. It's going to be the same thing, right? Well, no, it's not, because at x equals 0, you get 0 over 0, which is undefined. So there's a hole here. Now, why aren't these two the same function? X over x is not equal to 1 for every value of x, because when x is 0, the function is undefined. Now, here's the concept that I want to talk about involving limits. The limit as x approaches 0 of x over x is in fact still 1. Wait a minute, but x over x isn't 1. I just said that, at least at x equals 0. So how come the limit as x approaches 0 is still 1? Well, the important thing to note is that what does it approach when it is really, really close to 0? 0.000000001 over the same number is in fact still 1, and negative 0.0000001 over that same number is also still 1. So the closer you get to 0, it doesn't actually change the final result. It's always going to be 1. And so even though that at x equals 0, it's undefined, the limit as it gets closer and closer to 0 is still going to be 1. This may not look the same, but it really is the exact same as 1 over x, the limit as x approaches 0 from the positive direction going to positive infinity. Because at x equals 0, it's not really defined. Infinity isn't a defined number, but the limit does approach something. It approaches infinity. Now that you understand that concept, let's do a quick problem. What is the limit as x approaches 2 of x minus 2 over x squared minus 3x plus 2? Now, the general way you evaluate a limit is you just start by just plugging in the number, right? If you plug in x equals 2 here, you'll get 2 minus 2 on the top. Okay, well, that's easy enough. That's just 0. And then on the bottom, wait a minute, it doesn't matter what we get on the bottom, right? The top is already 0, so the whole thing is 0. Well, no, because we have to check if the bottom is 0, because if it's 0 over 0, then it's undefined, and it's no good. Let's check. The bottom is 2 squared, that's 4, minus 3 times 2. 3 times 2 is 6, and then 4 minus 6 is negative 2, plus 2. Negative 2 plus 2 is 0, so now we have 0 over 0. Okay, so the limit doesn't exist. Surely, 0 over 0 is undefined, right? Well, here's the thing. We can actually rewrite this limit. This is still the limit as x approaches 2 of x minus 2, and then we'll rewrite this polynomial into a factored form. This polynomial is the same as x minus 1 times x minus 2. And now, all of a sudden, we can cancel out this x minus 2, and then we'll get the limit as x approaches 2 of 1 over x minus 1. This, we can just plug the 2 in. 2 minus 1 is 1, so it's 1 over 1, and we get 1 as our final answer. Now, this really is the exact same concept as we saw before, where x over x is the same as 1 everywhere except for where it's 0 over 0. The same is true here. At x equals 2, this expression is 0 over 0, but otherwise it's completely identical to the expression 1 over x minus 1, so we can use that function to find the limit at its undefined point. Let's do one more example problem together, and then I'll send you on your way. So it'll be a short video today. So for our last question, let's make it a little bit more challenging. I'm going to ask you to evaluate the limit as x approaches positive 4 of x minus 4 over the square root of x squared minus 16. Now, what is this going to be? Feel free to pause it and try it on your own. I encourage you to. I think you really can with the skills that you've learned from the last problem. But if you have already tried that, all right, let's go ahead and get started. Now, the first thing that we have to do is realize that this is, in fact, a 0 over 0 problem. If you plug in 4 here, 4 minus 4 is 0. You plug in 4 here, 4 squared is 16. 16 minus 16 is 0. Square root of 0 is still 0. So we have a 0 over 0 problem. So how can we rewrite this? Well, looking at this, I'm going to assume that the limit is still there. I'm not going to bother rewriting it. We'll have x minus 4 over the square root of, and we're going to factor this as a difference of squares. This is x plus 4 times x minus 4. Now, how does that help us? We have an x minus 4 here and an x minus 4 here, but one's in a square root and one's not, so can we really cancel them out? Well, we can at least reduce the power of the one on top. Check this out. This expression is equal to the square root of x minus 4 over the square root of x plus 4. Now that's because x minus 4 over the square root of x minus 4 is, of course, the square root of x minus 4 in the same way that if you had 2 over the square root of 2, you would just get the square root of 2 because it's asking 2 divided by the square root of 2. Well, what times the square root of 2 is 2? The square root of 2. By definition, that's what a square root is. It means that you have to multiply it by itself to get to that number. Anyways, where does that net us? Well, let's try plugging in that 4 back in. We get 0 on the top and then square root of 8 on the bottom. Now it's no longer a 0 over 0 problem, but we still have a 0 in the numerator. Is that okay? It totally is. There's no problem with having a 0 just in the numerator, only if it's in the denominator. So the limit to this problem will be 0. And that's our final answer. I hope you guys enjoyed today's video. I know it's on the shorter side, but hopefully you are still able to learn a bit about limits here, and hopefully you'll be able to apply these skills in your math class later on. And as always, thank you so much for watching.